So the first one I want to look at, we're going to look at number 31 on the packet, second page. Oops, lost my... So we've got... Come on. This shape here. First thing we can find is dimension B here. What's that going to be? .36, yes. Millimeters. How about dimension C? Careful. Get 72 millimeters. I'm going to pause a minute.
Dimension C?
Yep.
72.
72. Anybody have questions on where I got those?
0.5 is T?
That's the next one we're going to get to. So then T is right here. It's T to 1. So I can do T to 1 or 1 to T, however I want to set it up. It's describing this surface here, so we have to use dimensions of that surface. So T is vertical. The vertical dimension there is 36. 1 is horizontal. The horizontal dimension there is 72. So it lines up like that. Always vertical to vertical, horizontal to horizontal. And then if we cross multiply and divide, 1 times 36 divided by 72, T is 0.5 or 1/2. Any questions? Okay, number 32. What's that? Well, for letter A,
Do 39.
do 39. We'll get to 39. For number 32, A is 40. B, 50. C, 20. Any questions on that one? $33. A here is how much? 24. Good. B? Careful. Went the wrong direction with it. Okay, so if we're looking at this surface right here, either one of these, right? The horizontal is going to be 24 on both of them. It's a 2 to 1 ratio, aspect ratio. 2 is the vertical, so 2 goes with B. 1 is horizontal, so 1 goes with 24. Cross multiply and divide there, B is going to be 48. So B is 48 millimeters. 48 plus 32 tells us that C here is 80 millimeters.
I got C was 48.
Okay, you might have been taking C the wrong place. C is this whole side here.
Yeah.
Oh, if you got 16 here, it would have added up.
I didn't
48.
get 16.
You subtracted.
48 was C, A was 24.
Okay.
So I didn't do B.
Gotcha.
1, so we have 24, A, 24.
It's 2 to 1, right? 2 is vertical. 1 is horizontal. So you got 2 to 1 here.
Yeah, we only have 24.
Yeah, 24 is horizontal, so that has to go with the 1. Horizontal has to go with horizontal. The 1's a horizontal dimension, so it must match up with another horizontal dimension. Number 34, how many threads are on a bolt that's 2 1/4 inches long? Well, it is a 15 thread per inch. So 2 1/4 inches, if it is 15 threads per 1 inch. Set it up like that. You can cross multiply and divide. You're going to get, what, 33 3/4 threads? What's that?
Becoming
18? Nope, because there's 15 threads in 1 inch, right? So it'd just be 15 times 2 1/4, or 2 1/2, sorry. 2 1/4, not 2 1/2, 2 1/4. 15 times 2 1/4 gives you the number of threads in 2 1/4 inches. Because 1 inch is 15 threads. 2 inches would have to be 30, so 2 1/4 has to be slightly more than that. The threads have a 2-to-1 rise to run ratio. So here's the thread. This is the rise. And the run is just half the width of the thread. They want to know how deep are the threads. In other words, what is the total rise on the thread? What is this dimension? They may be looking at it thinking, I don't know the run. But if this is 15 threads per inch, this total width of a thread has to be 1/15 of an inch. Does that make sense? There's 15 of them in an inch. Each of them is a 15th of an inch. Which means then that the run must be half of a 15th. 1/15 divided by 2 is a 30th of an inch. Does that make sense? So then your rise, if it's a 2-to-1 rise to run ratio, if the run is 1/30th, that goes on bottom. Cross, multiply, and divide. This is 1/15. Any questions? The rise has to be a 15th of an inch. Okay, number 36. Did anybody get an answer for number 36? Okay. We're going to come back to number 36. $37. So this is 7/8 of an inch here. Here to here is 9/16. This is 0.375. And we've got a 2-1 ratio. We want to find x. So the whole distance here is 3 inches. Well, we know what we're looking at is this surface here. So what we're looking at is basically this triangle right here. Do we know any of the dimensions of that triangle at all? Yes, which one? Yeah, this piece right here. Because it's half the difference between 3/8 and 9/16. 9/16 is 0.5625. We subtract the 3/8, the 0.375, which is the difference of 0.1875. That's the total difference. Well, that includes here and here. So we've got to divide that in 2. 0.09375. Is that size. Now then we set up the portion here. We got a 2-to-1 ratio. Which one does the 0.09375 go with? The 2 or the 1? 0.9375 is right here. It's vertical. So it has to go with the 2, which is vertical. So we cross multiply and divide it as 1 times 0.09375 divided by 2. Which gives us 0.046875. Now there's a whole concept of significant digits here as to where we should be rounding that. We're not going to get into that discussion here because you guys are not in the design side of it. If you're in the mechanical design side, that'd be a little more important. But there is a way you should be rounding these so you don't put in extra information that isn't there, but we're not going to deal with that. 38. Basically, 38 forms a triangle. From here to here is labeled as 3.438. From here to here is labeled as 2.188. And here to here is labeled as 3.250. And you are asked, there's a center line here and here, those are parallel lines. What you're asked to find is that dimension between those lines of center. Did anybody get for an answer? It's actually a little large. This is one where you need to find two different ways to come up with the same answer. Here's a triangle. I can find the area of that triangle two ways. One way is the area of the triangle is 1/2 base times height. I know the base is 3.250. The height is x, is what I'm looking for. So if I knew the area, I could find x. Well, what's a different way we know of to find the area of a triangle? It's only if it's a right triangle does that work. We don't know if there's any right angles there. In fact, we're assuming x is forming a right angle. Looking familiar yet? Yeah, the perimeter is 0.8 or 8.876. The semi-perimeter is the perimeter divided by 2, 4.438 inches. So the area is the square root of the semi-perimeter times the semi-perimeter minus the shortest side times the semi-perimeter minus the middle length side times the semi-perimeter times the longest side. Because that's the only way we know of to get back to find x here. If we knew the area, we'd find x because it's just 1/2 of this base times this height, where x is the height. So let's punch this in. I get 2.966 is my area. So then, going back to this formula, 2.966 equals 1/2 times 3.250 times x. So I'm going to take my 2.966, I'm going to divide by 1/2 or multiply by 2, then divide by 3.25. I'm getting 1.825. That seems a bit off. I must have punched something in wrong here. Because the answer is 2.12, so I must have punched something in wrong on this formula when I punched it in. Not uncommon for me to miss a number. I'm going to try her again. So there it is, 3.444. So that times 2 divided by 3.25. There it is, 2.120. So x is 2.120. Any questions?
What was the result of
The area?
Oh, yeah, the area.
The area was 3.444. So that one's just one you got to think a little bit outside the box. Any questions?
Is there some trig function other than the diagram here? I'm not showing that up.
Law cosines. That one's a few weeks away yet, though. 39. So we got that this is 13/16 of an inch from here to here. And this is 4 3/8 inches here. 3 5/16 here. It's obviously not drawn to scale. 2 7/16 there. This dimension here is 1 7/32. How did I get that? 2 7/16 divided by 2. So now I can find this dimension here because I have similar triangles. I have this triangle right here. It's the 13/16 and 4 3/8. Then I have the bigger triangle here. It's the 1 7/32. And I'll call this y for now here. So the y corresponds to the 4 3/8. The 1 7/32 is from the same triangle as the y, so that's to go on top. Corresponds to the 13/16. So let's cross multiply and divide. 4 3/8 times 1 7/32 divided by 13/16. 6.5625 we get the total distance from here. Now I need to know what's the distance from here to here. So I'm going to subtract the 4 3/8, which is 4.375. $2.1875. So then x, which is this dimension, is just the 3 5/16 minus the 2.1875. So x is 1.125, or 1 1/8 inch. Questions? Okay, number 40. In fact, I'm going to do number 41 first, then we're going to come back to number 40. For number 41, I'm going to draw it out a little rougher than the picture shows. You got a 10-inch pulley and a 7-inch pulley. We know the 7-inch pulleys run at 1200 RPM. Remember, this is inverse proportion. Pulley gets larger, the RPMs get smaller. So this is where we do 7 times 1200. Size times speed for one pulley equals the size times the speed for the other pulley. So 7 times 1200 is 8400 equals 10 times x divided by 10 is 840. Any questions on 41? All right, now coming back to number 40. So we're starting out with a 4-inch pulley at 1800 RPM. Connects with a 6-inch pulley, which is attached to a 3-inch pulley, and we got 1300 RPM coming out the back end. So we've got a relationship between these two pulleys. So it's 4 times 1800 for that first pulley equals 6 times its RPM for the second pulley, the 6-inch pulley. So 4 times 1800 divided by 6 is 1200 RPM. So 6-inch pulley is turning at 1200 RPM. How do we find how many RPM the 3-inch pulley is turning? Three-inch pulley is turning 1200 RPM. Why? They're on a shaft, not connected with a belt. They're on a shaft, so they must be turning the same RPM. The 6 and the 3-inch pulleys are connected. They're not running through a belt. It's the belt. It's the transfer through a belt that you have to adjust the RPM for. If they're on the same shaft, they must be turning the same RPM. So now to get to this other one, if this size is X, we've got the 3 times 1200 equals X times 1300. So 3 times 1200 is 3600 equals X times 1300. We're going to have to divide by 1300. So 3600 divided by 1300. 2.769 inches. Is the size of that pulley. Questions? Which type of problems seem to be giving people the most trouble so far? Pulleys or the aspect ratios? Aspect ratios. So let's do one like number 42. Trying to find dimension X. This is a 3:1 aspect ratio, 5 inches up here. 3 1/4 inches and 1 3/4 inches. What we're going to do is we need to find this dimension right here, which I'm going to find called dimension A for now. That dimension is going to be described off of this surface, because that 1:3 aspect ratio is describing that surface. So I'll put 3/1.
How do you know that's the surface that it's describing?
It's the only sloped surface. That symbol always means it's describing an angled surface. And generally, if you look at this, this forms a triangle with one side missing. That missing side should correspond in orientation to the side that it describes. So, do we know either of the dimensions of this triangle here? 3 1/4 is this dimension right here. Does that match up with the 3 or the 1? 3, because they're both vertical. So 1 times 3 1/4 divided by 3 is 1 1/12 of an inch. So A is 1 1/12. So I have to subtract 1 1/12 twice from the 5, which is going to give me 2 5/6 inches, or 2.833. Number 43 is one of my favorite problems. Not because it's painful, no, that's not why. Because it shows a very trig-like problem done fairly simply without trig. Okay, so we're going to find dimension y here. We're given that this is 0.200 inches. Here to here is 0.250 inches. The diameter, 0.150. And 1:1. What we're asked to find here, X, how far does the ball stick up out of the groove? And Y, what's the flat bottom of the groove? How big is the flat bottom of the groove? Well, I'm going to start out with this surface here. Makes that triangle. Do we know this side of the triangle? And that's just the depth of the groove. So if that's 0.2, this is 0.2. Why do those have to be the same? 1:1 ratio. Yep, the 250 minus the 200 is just 50 thousandths. So y is 0.050. Up here in the ball, that's a diameter of 150. It is a radius of 75. And remember, a radius is always perpendicular to a tangent. So that side here, this side here, has to form a right angle to that radius. Going this way, that must also be a right angle. That must also be 0.075. Question is, what do those have to be? So we're going to take a look at this purple triangle here a little bit closer. What do I know if I call this dimension A and B? What do I know about A and B? They're the same. If this is a one-to-one slope and it's perpendicular to a one-to-one slope, remember, the slope of something that's perpendicular is opposite reciprocal. Well, the opposite would make it negative, which doesn't matter, but the reciprocal of one-to-one is one-to-one. So it's just a negative one slope instead of a positive one slope. So it's still one-to-one. So what I can do is this. I can just say B equals A. So this is side A and this is side A. Now this is a right angle. How do I know it's a right angle? Yeah, vertical and horizontal are always at right angles to each other, right? Vertical has to be at a right angle to horizontal. So now we can use A squared plus A squared equals 0.075. So 2A squared equals 0.075. How do I solve that equation? Divide by 2. A squared equals 0.0375. And then square root. So the square root of 0.0375. 0.1936 inches. That does not seem right.
Would it be 0.075 squared?
Oh, I got square root of 0.075. That's what I missed. Thank you. Yeah, so that's 0.075 squared. Let's back up. Thanks, Carter. So this is 2A squared. This is 0.075 squared. Helps if I do my full math, right? So it's 0.005625. That has to be divided by 2. So 0.0028125. And that's what gets square rooted. .053, that's better. 0.053 inches is what that dimension is. So this is 0.053. This is 0.053. Now, to get the height up here, we're going to reference off the bottom of this. There are 3 dimensions that come involved. From the very bottom up to here, which is where it touches this surface. There's from here to here, which we just found to be 0.053. And there's from the center to the top, which is just the radius of 0.075. So we've got to find this one down here next, which is just a matter of finding how far up this surface do we have to go to get to that point of tangency, which is just the same as asking how far is it from here over to here. Well, that's 0.075 plus 0.053, right? So 0.075 plus 0.053 is 0.1258, no, 0.128 inches total from here all the way to here. Well, the slope doesn't start till here. How big is this bottom piece? 50. So we're going to subtract the 50. So this is 0.078 inches from here to here. Which means from here to here is how much? 1-to-1 slope, right? 0.078.
Too many lines.
I know, there's a lot of scribbles up there. Do you want me to go back and step through that all again? Try to draw it out bigger? No? Well, a lot of things you can do with ratio and proportion. A lot of things you can do with trig that you can actually do with ratio and proportion without knowing the trig. Sometimes. When you get into the design side, there are a lot of times where they test threads or measure threads with a BB in the thread. Yeah, thread wires and stuff. It is, but part of our purpose through this semester is to go through figuring out where some of those formulas in the machinist handbook come from.
So this is how to figure out what size wire I need?
Partly.
So which wire that tells you what size wire you need? Because it gave you the dimensions from the thread.
Yeah, this isn't a specific. This isn't necessarily specific except that because it doesn't slope on both sides. It's just similar to that application of dropping a gauge wire or whatever into a groove to test it. Excuse me. This actually particular problem is part of the problem that GM put out like 30 years ago for testing their machinists coming in for hire. Yeah, it's the theoretical concept that has similar applications, but not the specific. It's got all the concepts that are involved in here are involved in tasks that you would want to do, but not the specific task. So, again, we had a diameter of 150, which makes our radius 75 here. I'm going to leave the inches off just to keep it from being cluttered. So that means here, this is 75 thousandths as well. These have to be the same, so that's A and A. Did you guys follow me to the point where I found that A was 0.053? It was 53 thousandths? Or do you want me to go back through that? You don't have a clue? Okay. Okay, so this is A squared. These have to be the same, so I'm leaving them both as A. So A squared plus A squared has to equal the hypotenuse of 0.075 squared. A squared plus B squared equals C squared. Well, A squared and A squared is 2A squared. This is 0.0. Of course, I don't have it there anymore. 0.005625. That's this squared. 0.075 squared. Now you're going to divide by 2. A squared equals 0.00282125. Then you're going to square root it. So A equals 0.053. The square root of this is 0.053. So that tells us that each of these dimensions here and here is 53 thousandths. So now that tells me the distance from here to here is at 53 thousandths plus this basically forms a rectangle here, so this has to be 75 thousandths here as well. So that tells me this whole dimension from here to here is 75 plus 53. 128 thousandths of an inch. Does that make sense so far?
I just don't understand how you set these problems up. That's what I'm confused.
Well, and that's part of it is just seeing more of them. This is the first one we've seen where you had to use the aspect ratio like that rather than, you know, setting up in a proportion, cross multiplying and dividing. So we've got 0.5. This is 50 down here. If that's 50, that means this is 78 because I got 128 minus 50 makes 78 here. So if it's 78 from here to here, that's a 1-to-1 aspect ratio. That means this has to also be 78. So if that's 78, that was one of the first thing we figured out just by doing the. If this is 200 here, this is 200 here, because it's a 1-to-1 aspect ratio. Subtract that from the 250 gives you 50 here. So now that we know that's 78, that means from here to here is 78. From here to here has to be the 53. And from here to here has to be that radius of 75. So yeah, 75 plus 53 is 128. Plus 78 is 2.006 inches. How about 0.2006 inches? All the way up. Well, how far is it? Up to here? That was labeled as 200. So that means X, this dimension right here, how far that sticks up above? 6 thousandths of an inch. Okay, tomorrow we're going to go over more of these. Tomorrow we will start on 44 and go from there. We will come back. At this point, like you said, you should be done up through 70. Yeah, 71, you're right. 71 you should be able to be done through. Have a good one, guys. No new homework today.